Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading are helping you out. This is video number 17. Please do wait for a total number of 33 questions, guys. Ne? Let's just get right into it. Uh, the relationship between boiling point and the number of carbon atoms in straight chain molecules of alkanes, carboxylic acid, and alcohols is investigated. Curves P, Q, and R are obtained. Okay, we are dealing with alkanes, uh, carboxylic acids, and alcohol. Okay, I know that my alkanes will have the lowest boiling point between the three organic compounds. Are we together? Why am I saying that? Because alkanes have weak London forces. Since the intermolecular forces that exist between alkanes is weak, that means it will have a lower boiling point. So curve P represent alkanes. Are you together? And then now I have to contrast between a carboxylic acid and alcohols. Carboxylic acid has two sides of hydrogen bond, and alcohols only have one side of hydrogen bond. So that makes carboxylic acid to have stronger intermolecular forces compared to alcohols. So since carboxylic acid has stronger intermolecular forces, we can therefore conclude that carboxylic acids are the one that has the highest boiling point. So a carboxylic acid with only one carbon has that amount of boiling point, which is higher than this amount of alcohol and that amount of alkane. So curve R represent carboxylic acids. Acid. My handwriting. Okay, so since curve R is carboxylic acid and curve P is alkanes, that leaves curve Q to represent alcohols. Okay, before I even answer the questions, guys, we've already analyzed these curves. Ne? Let's go and answer the questions now. We are being asked to define the term boiling point. Boiling point is a temperature at which the vapor pressure of a substance is equals to its atmospheric pressure. Okay, for curve P, write down the conclusion that can be drawn from the above results. For curve P, remember that, guys, in this question we are investigating the relationship between boiling point and the number of carbons in straight chains. Okay, the conclusion will be that uh, the the more carbons that the longer the chain, rather, the greater the boiling point. Let's check here. If we have our if we have one carbon on our alkane, that will be methane. Methane has that amount of boiling point, which is very very low, between 200 and between 100 and 200 kelvins. Are we together? And then whenever we have two carbons, that means we have an ethene. The boiling point will be a number which is higher than that of methane. Are we together? If you have three carbons, the boiling point increases. Four carbons, boiling point. For butane, boiling point increases. Pentane, boiling point increases. Hexane, boiling point increases. Heptane, boiling point also increases. Are you together? So we can therefore conclude that the longer the chain of alkanes, or rather the longer the chain, the longer the chain of an organic compound, the higher the boiling point. Are we together? Our conclusion will be the longer the straight chain, the higher the boiling point. Okay, now you are supposed to identify curve PQ or R that represents each of the following. Remember that we said that curve P represent alkanes. Why? Because it has the lowest boiling point. Are you together? And then curve R represent carboxylic acid because it has the highest boiling point compared to alcohols and alkanes. Okay, and then now we must fully explain the answer in 3.3.2 by referring to the type of intermolecular forces present in alkanes, carboxylic acid, and alcohol. Excuse me, the relative strength of these intermolecular forces and the energy needed. Excuse me. Okay, we can say that alkane has weak London forces. Together, and then alcohols have one side of hydrogen bond. And then let's continue. Carboxylic acid have two sides of hydrogen bonds. So this will therefore conclude that carboxylic acids have stronger intermolecular forces, and hence carboxylic acids will require more energy to separate the bonds, and then thirdly, hence carboxylic acid has the highest boiling point. Has the highest boiling point compared to the two compounds. This is how, guys, we're supposed to tackle this question over here. I hope you are seeing that, guys. These questions are just repetitive. Always the time you'll be asked to explain by referring to the intermolecular forces, the relative strength between the relative strength between intermolecular forces and the energy required. Are we together? So they are just repetitive, guys. Yeah, let's just move on to the other one. Thank you for your time. Just wait for the other video.